Before starting, just a small announcement. Also this year we have a social event and we have the banquet. The banquet will be at the Piano dei Mulini. It is a place nearby Campobasso. We still need the bus to go there, and this time the bus will depart from here in front of the main entrance of the Aula Magna at 6:30. Actually, this is a picture that was taken probably in summer. So this is something that you can see this evening, so be prepared. Okay, let's start. And it's my pleasure today to introduce our second keynote speaker, Jan Bosch. Jan is professor at Chalmers University of Technology in Sweden, and he is also the director of the Software Center in the same university. He has a great experience. He has more than 20 years of experience in large-scale software research and development, business and management. He is also the co-founder of a company, the Bosch. Okay. And he also was the vice president from 2004 and 2007 of the Nokia Research Laboratory. And he was also the vice president from 2007 and 2011 of Intuit. As a personal note, I actually attended a tutorial by Jan in 2006 at the International Summer School on Software Engineering in Salerno. I was a PhD student, and I was really impressed by the talk done by Jan. And also I was impressed by the passion that he put in the talk. If you look at this website, there is a slogan that I really like: passion to make things better. And I strongly believe that passion is one of the key ingredients to success. So I'm looking forward to attend your talk, and please, the floor is yours. Thank you.
Thanks a lot. Just a second. Always tricky. Let's see if this still works. Yeah, okay, good. So, good morning, everyone. How are you today? You having fun yet? We've only just started. It's 9 o'clock in the morning, right? Do I need the microphone, or can I do it without?
Yes, probably you need because.
Oh, because you are recording, right? Yeah, otherwise it doesn't work. I wanted to thank all the Italians. Can you raise your hand? Thank you for welcoming me with the most Swedish weather I've ever experienced in Italy. That was just amazing. I really enjoyed that. What a surprise. I thought, oh, here I go to a warm, sunny place. It's going to be so boring. No, actually, okay, no, in any case, it was surprising, to say the least. What I was hoping to do with you is to talk about a very fundamental change that I see happen in society and in industry. And I think that academia and research have significant implications on how that is going to play out. And that is one of the things why I think it's so important that we all are aware of the changes that are happening in the industry and in society. So what I believe is happening is that we are moving towards a fundamentally new way of organizing companies and even not-for-profit organizations such as universities and other organizations. And that has to do with the whole notion of digitalization. So I thought I'd try to make this interactive, and I thought I'd begin with a little quiz. Does anyone know who this fine specimen of the human species is? Anyone? I can tell you that you use a product that this fine gentleman invented every day. Yeah, go ahead. Exactly, Douglas Engelbart. He invented the computer mouse, and he has this quote: "The digital revolution is far more significant than the invention of writing and even printing." Understand what this means. The two fundamental technologies that were introduced in the history of mankind, writing and printing, that actually changed the course of humanity. According to this man, digitalization is a bigger deal than those things. Yeah, that's what is happening. And I know that it's easy to basically just live in the midst of it and never experience what is actually happening. But if you step back, this is what is going on in society right now. And we can see this happening as we speak, because if we look at how many companies were on the Fortune 500 in 2000, and how many of those companies were still on the list in 2014, we can actually see a rather surprising statistic. More than half of the companies that were on the Fortune 500 in 2000 are gone from the list in 2014. And actually, that's not a good thing. Hear what happened here, but this was not part of the program, I promise you. My computer is still doing what it is supposed to do. Can you pull up my presentation on your computer too, so we can switch if it becomes necessary? Let's see if this happens better. I'm glad we have a bit more time for this presentation. Do you have it open? We're going to switch computers. Oh, did it come back? Well, downloaded it anyway because I don't trust this thing anymore. Here we go. So if we look at the Fortune 500, actually over time the length of the tenure of companies on the Fortune 500 has constantly been shrinking. So it has gone from originally 95 years to 30 years in the early 90s to 15 years in the early 2000s to 10 years being the current number on how long companies on the Fortune 500. And the main cause why this is happening is because companies fail to build new core capabilities. And the biggest new core capability that we are now looking at is actually digitalization. So what is digitalization? I'm using a Gartner definition. I thought I would give you a lot of business consulting quotes today because you're all living in universities, right? Just to make you feel better. But I think that this is a quite good definition. Digitalization is the use of digital technologies to change a business model and provide new revenue and value producing opportunities. It's the process of moving to a digital business. And then if you look at Boston Consulting Group, they do a bit of an analysis of what does this actually mean in practice. And what we see is that basically many of the things that we as a community are concerned with are addressed by this topic. So what we see is that increasingly, of course, products are extended with software. So software is being added to them. But then if we talk about data-driven services and digital services, don't ask me for the precise definition, go to the website. As well as pure software products, those are now things that are being added to what we're actually doing. And this whole transformation does not just affect the research and development, it also affects sales channels and marketing, manufacturing, supply chain, HR, finance, and support. And this is not just about going agile, it is also about system and technology platforms, it's about analytics and data integration, and it is about building a digital ecosystem. So what we see happen, and what I'm hoping to do in this talk is to place the work that we do in the software engineering community in this context, is that there is a fundamental paradigm shift happening in society and in industry, which is affecting everything that we are basically concerned with today. And I think that that's what I was hoping to get across. Now, I know that you had your welcome reception last night, right? So I thought I'd keep this really simple. I only have 3 key takeaways that I'm going to ask you to remember after this talk. And the first is that increasing speed trumps any other improvement that R&D can provide to the organization. In almost every industry, the goal is continuous deployment of new functionality. And this is not just in the web context, this is now also in cars, in factories, in telecom networks, etc. All these industries are moving towards this is not a good experience, I must admit. Oh, now it's back suddenly. I don't know what's going on, but we'll switch at some point. Yeah, so this is the first takeaway. The goal is continuous deployment of new functionality, and how we do that is actually an interesting challenge. The second, effective use of data and from our customers and from our products in the field, as well as the ecosystem around our systems and the services in the field, are the next areas to exploit and monetize. Yeah, so I just heard from one gentleman in the audience who just joined the Data Science Institute. Good timing, I think, yeah? And then finally, we are moving towards a new business operating mechanism, which is much more focused on empowerment and autonomy, and I will talk a little bit about that as well. So this is what I was hoping to cover with you in the coming hour or so, and feel free to ask me any questions. We're not a terribly large group, so if you want to interrupt me during the talk, feel free to do so. I think it's much more fun to be interactive than to wait until the very end. So I was hoping to tell you a little bit about who I am and where I come from, then talk about what do I see happen in the industry, and then I want to talk about the 4 dimensions of a new business operating system, which are organized around speed, data, ecosystems, and empowerment. And by the time you see conclusion, you will be ready for a cup of coffee, I promise you. Yeah? So very briefly about me, I used to be a young and innocent professor of software engineering. In the early 2000s, as Rocco was already alluding to, I was hired by Nokia. I ran the Software and Application Technologies lab of Nokia, which was a really good place to be, because that were the days that Nokia was a fun company to work at. Then in the mid-2000s, I moved to Silicon Valley, worked for a company called Intuit. Not many of, mostly the Americans in the room will know this. Intuit is about 8,000 people, 4.5 billion in revenue. And today I spent some time in startups in my consulting business, and I run something called Software Center. Software Center is a bit of a different setup. It's a collaboration between 11 companies and 5 universities, and the goal of Software Center is to improve the digitalization capability of the European software-intensive systems industry. The interesting thing behind this center is there is no public money in this center. The companies are actually paying for being members in the consortium. Yeah, and that's, I think, a relatively unique setup. You don't see that often. But we have Tetra Pak, you know them from the milk packages. Yeah, but what most people don't realize is that they also build the machines that fill those milk packages, and they have very advanced mechatronics, robotics, and other solutions. Saab Technologies, Saab is not the bankrupt Dutch car company. For those of you that remember the story, this is actually the defense company Saab in Sweden that builds everything from radar systems to command and control systems and jet fighters. Siemens is in there. Bosch, unfortunately, no relation to me. Qualcomm is a small and medium-sized enterprise in Gothenburg. Axis Communications is now part of Canon. It's a web security camera company. We have Volvo Trucks and Volvo Cars in there. Jeppesen, which is part of Boeing, Ericsson, and Grundfos. And then we have 5 universities in there, Chalmers and the University of Gothenburg, which is basically the department where I work, which is a joint department between both universities, Malmö University, Linköping University, and Mälardalen University. And our goal is fast, continuous deployment of customer value. How do we get stuff out to customers as rapidly as possible? The topics that we look into are things like continuous delivery, continuous architecture. So in the continuous delivery, we look into continuous integration and continuous deployment. In architecture, we look into architecture, technical debt management. We look into interoperability, etc. Metrics is a topic that we spend a lot of time on because some of the companies in the Software Center are very advanced, and we have some leading researchers in the field there as well. Together with one of my colleagues, Helena, she runs the customer data and ecosystems theme where I spend quite a bit of time. But there is also some other activities. The Wallenberg family in Sweden allocated what I think now is 2.8 billion Swedish kronor, which is like 300 million euros, for a very large program about autonomous systems, software, and artificial intelligence, which is the WASP program. So we are connected to that. And then at the university, Malmö University, they have a program around Internet of Things. We do not only work with traditional metal bending companies, we also connect with several of the online companies. So we have connections at Booking, at Spotify. Rovio is, for those of you that remember Angry Birds. Klarna is a company where you can basically get credit after you buy stuff online. King.com is the company behind Candy Crush. Microsoft, we have had one of our PhD students now spend 2 summer internships there, and he's probably starting there after the summer. And we have a second PhD student that had started to do research with them as well. So there's a lot of activity going on in the Software Center. So that's where I come from and what the background is of what I'm going to be talking about. What I wanted to do next is talk a little bit about what do I see as the big trends in industry. Someone mentioned to me this morning, it was David, who said it's a good time to be in software. And that is absolutely correct. If you look at the Gartner Technology Hype Cycle for 2017, if you look at all the topics that are on the list, on the innovation trigger, on the peak of inflated expectations, in the trough of disillusionment, or moving their ways towards the scope of enlightenment, almost all those topics have software involved in them. If you go from virtual reality or augmented reality, or software-defined security, or cognitive expert advisors, or blockchain, or machine learning, deep learning, every one of these topics is actually driven by software, and it's important to realize that. One of my favorite futurologists, Gerd Höfner, he looks into what are all the technologies that are shaping up right now. And again, you can see that almost all those technologies are driven by software. And then what are the scenarios, the disruptive scenarios that are actually playing out right now in society? Again, we can see there are lots of things happening, and all of this, or almost all of this, is driven by software. So it's a good time to be in software. The first thing that I wanted to point out here, automation of everything. For a very long time, we have been using software and IT to support humans in doing a better job. What is now happening, the transformation that is now happening, is that we are moving towards an age where software and computers will replace human beings. So we do not have driver support in cars. We are replacing the entire driver in cars. We're moving towards self-driving cars. We do not have software that supports financial advisors. No, now we have robot advisors that replace the financial advisor. Now what we see is that in industry and after industry, humans are being replaced by algorithms. And that's, I think, an interesting development. The other interesting thing that is happening in a society where we are less and less able to rely on central authorities, for instance, central banks and other organizations, we are moving towards a world where we find solutions where we can build decentralized trust. So I don't need to have a central authority that basically gives credibility to everyone who buys into their system, which is of course what a central bank works like, but we're moving towards a decentralization. So think of blockchain technologies where you basically build trust through transparency and immutable transactions, which allows you to operate in a decentralized environment without, I think this is the moment, this is getting really annoying. Where we don't have to rely on a central authority. If you look at Google, Google wants to be the third half of your brain, which I think is an interesting statement. I'm not sure what that means. If you look at deep learning, one of the most interesting technologies that I now see popping up. I'm on the board of a startup in Stockholm, Peltarion, you can look it up. And they're building a platform for deep learning, and that is just a totally amazing story to see what you can actually do with convoluted neural networks and other deep learning solutions. And I think you all know the approach. You train the network and then you use it to give the right answers. And if we look at the world, everything we do these days is driven by software. When I get up out of bed in the morning, the first thing I do is I brush my teeth. How do I brush my teeth? I use an Oral-B electric toothbrush. In 2016, Oral-B announced a software ecosystem for toothbrushes. Yeah, they put Bluetooth in their toothbrushes, and through Bluetooth, your toothbrush can connect to your mobile phone. And then the mobile phone has an app that will give you feedback on the quality of your toothbrushing experience. How cool is that, right? And after that, the rest of your day is basically run by software. If you look at logistics, if you look at infrastructure, sports, agriculture, forestry, electricity generation, telecommunications, self-driving cars, even garbage collection these days is driven by software. One of the startups that we met about a year ago is called Enevo. It's a startup in Finland. They put ultrasound sensors in these big waste bins, yeah, for recyclables, for plastic and glass and other things. And what happens is that every so often the ultrasound sensor will sense how full the waste bin is and send the data back to the mothership. And what happens then is that garbage collection companies can dynamically optimize the garbage collection route because they know which bins are full and need to be emptied, and they know which bins they can actually skip this time. This results in a 50% reduction of garbage collection costs for these companies. So again, we see that everything we do these days is actually driven by software. Self-driving cars, of course, that's software. Robots, driven by software. If you look at the military, it's of course increasingly driven by software because we're moving from humans fighting to drones and robots fighting. And then finally, even the most backwards industry, construction. Yeah, there was a recent article in The Economist that basically showed that construction has had no productivity improvement since 1947. Yeah, so the year my dad was born, since that year, construction has had zero productivity improvement. But even that industry is now kicked into the 21st century, kicking and screaming through all kinds of technologies such as 3D cement printing, automated bricklaying, etc., etc. Why is everything moving to software? So I know that I'm not doing a deep technical talk today, but I think it's important to understand why our field is so central to making progress in society as a whole. You've all read The Lean Startup by Eric Ries, I'm sure, and he introduces a concept that he calls the build, measure, learn loop. And the build, measure, learn loop goes as follows. I have an idea. Based on that idea, I can build something that results in a product. That product I can put in the field so I can measure. When I measure, I get data. From that data, I can learn, and from that learnings, I can get new ideas. Yeah, this is the basic cycle of innovation. And the thinking is, the faster you can go through this loop, the more innovative you are. Yeah, so if we take the automotive industry, a car platform, this is an electric platform, not of a company that I know, but I think it's a nice picture. A car platform has a life length of about a decade to a decade and a half. So that means that I go through my build, measure, learn loop once every decade and a half. Which is, if you're lucky and you work for the same company for say 40 years or something, you will go through this loop 2 or 3 times if you happen to be lucky. Yeah. If you go for a car, an individual car, this is by the way the Volvo XC90, nice car, right? Made in Sweden. Not funny? Okay, I don't know. A typical car project lasts around 3 years, which means I go through my build, measure, learn loop once every 36 months. What about car software? Well, for car software, I can deploy new software into the car every week or even every day. And that means that if I also get data back from the car, it means I go through my build, measure, learn loop 100, 200, maybe even 500 times faster than any other technology that exists. And if I can innovate that much faster through software than any other technology, then obviously I want to move as much of my functionality into software, because that allows me to go through the fast innovation loop rather than being forced to go through the slow innovation loop of everything that involves atoms. This is, I believe, one of the key reasons why everything is moving to software. And we can see this, right? If we look at how much software is in systems and we measure that over time, this was done by people at Vector Consulting, I think, and a few others. You can see that depending on the industry that you're in, the size of the software in your systems goes up with an order of magnitude every 5 to 10 years. So on average, every 7 years, there is 10 times as much software in the systems as what we have today. And the interesting thing is that the solutions, architectural solutions, tools, processes, ways of working, etc., that work for a 1 million line of code system, they don't work anymore for a 10 million lines of code system. And 10 million lines of code systems, when you finally figured out how to build those kind of systems reliably and predictably, then those solutions do not work when you're trying to build a 100 million lines of code system. Yeah, and this is one of the interesting developments in software engineering. Last year, I was a professor of software engineering for 20 years. I'm that old, in case you wondered, yeah? And I have colleagues in other fields that ask me, Jan, you've now been a professor for so long. Have you still not solved the problem of software engineering? How hard can it be? And then I show them this graph, and I tell them, you know, every 5 to 7 years, I'm solving another problem. I'm solving a problem that is 10 times as large as what we were trying to solve earlier. This is the joy of being in software. Can you imagine being in an industry where the car that you build is 10 times as heavy every 7 years? Why would you build a car that is 10 times as heavy? It doesn't make any sense, but software, here it makes perfect sense because we can add more and more value-adding functionality to cars. And we can see this, right? This is a graph from Volvo Cars. I'm still waiting for the update because this one is from 2014. But if you look at it, the previous cars going back to 98, 1.5 megabytes of software in the car, growing to 100 megabytes in the car by 2011, 2012. Now the XC90 is actually well over a gigabyte of software in the car. According to my friends at Volvo Cars, it may come back, it may not come back, you may never know. Yeah. According to my friends at Volvo Cars, a modern car these days has more than 100 million lines of code. Imagine what it takes to build 100 million lines of code. Let's pull the plug and just be done with this. I don't know what's going on. You have my presentation? Yes. Sorry, give me a minute while we go and resolve our technical difficulties. Oh, you can use my power otherwise. Okay, just a second. We are getting there. Go to the slide where I was. Oh, that's okay. Over slide. There we go. Yeah, that's fine. Okay, and I plugged in. Let's see if this works. Let's see if this computer is more reliable than the previous one. Yeah, so 100 million lines of code in a modern car. That's a lot of software where I come from. And this is also one of the things that I want to send as a message to the academic community. If you are building solutions, and those solutions work for a few thousand lines of code, how useful are those solutions really in a context where now the most leading companies are building systems that are in the millions of lines of code? And I want you to think a little bit about that, and we can actually have a discussion towards the end of this talk. Data, I want to talk a little bit about data. It's very difficult to find accurate numbers, how much data gets generated in the world. I found one reference that said that 50 terabytes of data are created every second. I think that's a gross underestimation. Even a single self-driving car creates in excess of 5 megabits per second continuously. This is just one self-driving car. I think that this is maybe the amount of data that gets stored every second. Yeah, so there's a lot happening. If you want to have another perspective on this, here you have what is happening in 1 minute in the internet. Yeah, so if you're wondering, if you have kids, well, maybe many of you are too young to have kids, but in any case, if you have kids and you wonder why your kids never stop watching YouTube videos, it's because for every minute of the day, 72 hours of new video are uploaded to YouTube. Maybe you're in the dating scene and you're using Tinder, although no one will admit to using Tinder. I don't know why that is. I've been married since 95, so I don't know about that. But I've heard that Tinder is a kind of popular app. Yeah, so over the last minute, about 500,000 swipes took place on Tinder. I think it has something to do with left and right, but you can explain the rules to me after this. Yeah, 204 million emails were sent in the last minute. And this is just data generated by human beings. Now we're moving towards this whole Internet of Things world, where Ericsson is predicting that we will have 50 billion connected devices in a couple of years. What do you think those devices are going to do? They're going to generate vast amounts of data, far exceeding what humans are creating, because there are far more devices than there are humans out there. Yeah, so this is just a fraction of what will be created in the future. Yeah, what humans are generating in terms of data is just a fraction of what will be floating around in terms of data in the field. Yeah, I think that that's fascinating. Last trend before we go into a little bit more technical stuff is the need for speed. This is a slide that if you steal from, in research, if you steal from one source, it's called plagiarism. If you steal from multiple sources, it's called research. Yeah, so I researched this slide from some of the people that I used to work with. Yeah, so this is a slide that shows how long does it take for a product to reach 1 million and 50 million users. Here is Quicken, a personal financial management product from Intuit. That was introduced in 84. It took 6 years for that product to reach 1 million users. We never reached 50 million. 10 years later, eBay comes along. 30 months to 1 million, 80 months to 50 million. Then again, 10 years later, Facebook comes along. 10 months to 1 million, 44 months to 50 million. And then only 5 years later, Angry Birds comes along. Angry Birds hits 50 million users in about a month. They don't even know how long it took them to get to 1 million. They just flew past. Yeah? And anyone remember Pokemon Go 2 summers or 2.5 summers ago? Yeah, this is Italian summer, right? What we're experiencing out there. Yeah, so, I mean, that just was an enormous explosion. And what does this mean? It means that if we are introducing something into market that is really valuable for the users, customer adoption has never been faster. And you may have seen some of those graphs of how fast new technologies are adopted. We see that with every new technology that gets introduced into society, the customer adoption or the adoption by people in the society is only accelerating. It's always only getting faster. If you don't like customers, but you like money, here's a second example. I have a company. The company sells a product at $1 billion a year, which is actually quite normal for many of the companies that I work with. Most companies express their R&D budget as a percentage of revenue, so I put it at 10%, which gives me $100 million R&D budget. Yeah, in Sweden we have some issues with our math education, so I was first using another percentage, but people got confused, so now I try to make it as simple as possible. Was that funny? May I make fun of jokes of Swedes? I don't know. I'm Dutch myself, just for the record. Huh? Now I have my new product development cycle is 12 months. So from the moment that I decide to start my new product until I put it in market, I have a 12-month period. Now I'm going to give you two alternatives. The first alternative is I'm going to do everything I can to improve the efficiency of my software development. And lo and behold, I'm successful. I'm 10% more efficient. I'm still shipping after a year, or after 12 months, but I've only spent $90 million instead of $100 million. That's pretty cool, right? 10 million in savings. Even in Italy, after taxes, that's real money, right? Is that fair? Although I live in a country with the second highest income taxes in the world, just for the record. I'm not complaining, I'm just observing. Yeah. Alternative number 2, however, is I'm going to focus everything on speed, on reducing my development cycle. So I'm going to try to get a product out as rapidly as possible. And I'm successful. I'm 10% faster than what I've been doing in the past. Yeah? If I am able to be 10% faster, it means that I can start selling my product 1.2 months earlier. And if I am not cannibalizing any existing business, and if I am selling at a flat rate of $1 billion a year, just by being faster, I'm adding $100 million of additional top-line revenue to the company. What would you rather have, 10 million in savings or $100 million of additional revenue? Right? Hold on, you're thinking? Yeah. You know, typically when I pose this to the audience, most people in the audience will say, or someone in the audience will say, I want both. But that was not what I was offering in this situation. But look what's happening. You have earned back your entire R&D budget just by being faster. Just by being faster, you've earned back the 100 million that you put in your R&D budget. There is nothing that you can do from an efficiency improvement perspective that will outperform a cycle time reduction. If you're wondering why Agile and continuous deployment and DevOps and all these things are happening, it's because of this. Because it goes from idea to in-market so I can monetize faster and faster. And we're going to talk about that. We're going to talk about this new business operating system. Yeah, so for this, I'm introducing an extremely simple model that I think you can read about in IEEE Computer. I just have to check the clock to see if I'm going too slow or fast enough. I'm going too slow. Yeah, this is the 3-layer product model. It's a super simple model. I'm actually not a very smart person, so I can only do simple models. So what is happening is that every product, every platform, every product portfolio has 3 layers of functionality. I have a layer of commodity functionality, stuff that I need for my product to work, but no one will buy your product or your system or your solution because of that functionality. Think about when you bought your latest mobile phone. The fact that you could make phone calls with that mobile phone did not factor into your buying decision. You would have been really annoyed if you couldn't make phone calls with your mobile phone, but you assumed that it was available. It's just a commodity function. Are you with me? You understand? On top of that, there is a layer of differentiating functionality. Functionality that I can use, that causes my customers to buy my product instead of a competitor's product, because I can do things that others can't. And on top of this, there is an innovation and experimentation layer where I run as many experiments as I can in order to figure out what are the future differentiations that I can put in my product. So the typical process is I run 10 innovation experiments. One of them really resonates with customers, so that one I productize and I put into the differentiating functionality layer. It sits there for a while. Depending on the industry that you're in, this may be a few weeks, a few months, or a few years. And then it commoditizes, customers are less interested in it, competitors have caught up with it, so then it becomes commodity and becomes part of the commodity functionality layer. So this is the typical, I'm using this model to basically discuss this new digital business operating system that we're moving towards, because these are the questions that if you would ever start a company, and some of you are working at a company, you're asking yourself, how do I expand my innovation funnel? Well, for that, you want to partner with your innovation ecosystem as much as possible. Once I find something that is really valuable, how do I deliver it to market fast? Well, for this, I need speed. We're going to talk about that. How do I know that what I'm building provides value for customers? Well, for this, I need data. How do I know when functionality is going from differentiating to being commodity? Well, for this, I need data. How do I minimize total cost of ownership for commodity functionality? Well, for this, I need the ecosystem. And then how do I organize around all this? Here, I focus on empowerment. So what I'm saying is, we're moving towards a new business operating system which focuses on speed, so it gives me business agility, data so I can instrument and measure everything I do, the ecosystem so I can focus my own resources on differentiation, and I want to empower teams so I can move fast. This means that this model has 4 dimensions, and I'm now going to talk about the 4 dimensions. I realize I'm running a little bit behind schedule, so I'm starting to talk faster. Is that okay? Yeah? Well, it doesn't... So this is based on dozens of companies that we've worked with, the typical process that companies go through when they work with speed. We start with traditional development, and the first step after that is that you adopt Agile. And Agile is in some way a simple change because it only affects the R&D teams. Once I have Agile in place, I move to continuous integration. With continuous integration, every time I check in within minutes, hours, or days, I have feedback on what I've built. And I know that what I've built is actually production quality. Or if I broke anything, I know what I broke and how to fix it. The interesting thing in many companies, in the past they had a situation that the company couldn't ship the product because software wasn't done. Yeah, or they hadn't they didn't have the quality under control yet. When you're done with continuous integration, you will always be able to ship as a company. So the R&D will never have to tell the business side of the company, we can't ship yet. No, they will say, we can always ship, and if you want to ship now, we can do that, but then you will not have these and these features. And if you want to ship, if you're willing to wait 1, 2, or 3 sprints, then we can ship with those other features. Once you have continuous integration under control, most companies move towards continuous deployment. Yeah, so then they get software out at least every agile sprint, although some companies are releasing multiple times per day. And then finally, once you have continuous deployment under control, you can move to what I call R&D as an innovation system. Then you can start to use your installed base for A/B experimentation. So say you have 100,000 cars in the field, you can give 50,000 cars a version A of a certain feature, you can give 50,000 cars, other cars version B of the same feature, you can measure how the feature performs in practice, and based on that decide whether the A alternative or the B alternative is better. And if you go to modern web companies, some of them that I showed on the earlier slides, they are running thousands of A/B experiments concurrently in parallel. One of the companies, the former CTO of that company, told me that in 2016 that company ran 30,000 A/B experiments on their online product. Yeah, so this is a real thing. Why do we care about this? Well, I recognize 6 feedback cycles. There's the development cycle, building the next functionality to build. There's the requirement cycle, deciding what to build next. There's the quality assurance cycle, the governance cycle. Most development teams divide their resources between feature development, fixing defects, and architecture refactoring. So how often can I reprioritize that? The deployment cycle, and then the value creation cycle. If you go through these 5 steps, then what you see is that initially all these feedback cycles are long. They tend to be very slow. They are measured in quarters or in years. But as I move to Agile, my development and requirement cycle become fast. When I move to continuous integration, my my quality assurance and governance move fast. When I move to continuous deployment, my deployment cycle moves fast. And then when I'm in the last stage, everything is fast. And why is this important? This is important because if I need to make a decision about anything in R&D, and I have to wait 6, 9, or 12 months before I get feedback on whether that decision was a good one or not, I will take decisions based on opinions. But when I take a decision and I can get data in 1, 2, or 3 weeks, then I can move towards data-driven decision making. And we're going to come back to that, but one of the things that we have found is that more than half of all the features and functions in a typical system are never used, should never have been built. So we are very poor at making decisions about what to build. We've done quite a bit of work in this area. This is work with Antonio Martini, who some of you may know. He's Italian. He recently became an associate professor in Oslo, where we looked into architecture technical debt management. I'm not going to go into this, but it's interesting work. We've also worked, for those of you that are interested in continuous integration, we've developed something called the CIVIT model, Continuous Integration Visualization Technique. And what it basically says is all the test activities between an individual engineer working at the component level to final acceptance testing at the customer. So, and here you see the little boxes. F stands for functionality, so that's the what am I testing of the functionality that is being developed in this sprint. L stands for legacy functionality, Q stands for quality attribute, E stands for edge cases, and the color coding is how much coverage of those requirements do I have at this stage in the testing process. The line around it indicates the level of test automation. So if you go to this company, this is one of the software center companies, an individual engineer before promoting the software that he or she developed will first run tests in his or her own sandbox. Then it goes to the team sandbox where there is some more testing is taking place. Then it goes to the main branch. This company employs single branch development. There is some acceptance testing before the code is let into the main branch. Then every 2 hours, fully automatic, a continuous integration test system is kicked off that takes all the code developed over the last 2 hours and runs it through a test suite that fits in a 2-hour window. So they take the highest priority tests. Then every evening, at, I think it was 7 or 8 o'clock, they kick off a 10-hour fully automated test suite. It's not my computer, I think. It's back, okay. So we have, so every hour, every evening, there is a 10-hour test suite, and then in the night, on Friday night at 8 o'clock, they kick off a fully automatic 50-hour test suite that runs through all the test cases that are available for this multi-million lines of code system running on 3 different hardware configurations. And at the end of that weekend, if no major issues have been found, people typically feel very good about the quality. At this point, this company still had a separate release organization, a separate release process. By now, they have actually adopted continuous deployment in the embedded space. But that's one of the other things that we did. And then finally, for those of you, anyone here working on variability management, software product lines, and related topics? No, then I'm going to skip this slide. If we're going to talk about data, similarly to the speed dimension, also in the data dimension, we see that companies move through a very predictable model. They go from working with data in an ad hoc fashion where the collection is manual, the analysis is manual, the reporting is manual, and the decision making is manual. The next step is collection. When you move to collection, all the data is collected automatically, but all the analysis and reporting and decision making on that data is done manually. So for those of you that have a car, every time your car goes to service, the mechanic will put a big stick into your computer, or into your car, will suck out all the data on how you've used the car since the last service and send it back to Volkswagen, Mercedes, BMW, Volvo, or any other brand that you have. Yeah, or whatever it is that you have. And this has been happening since the late 90s. When you actually buy a car, you sign off that you're okay with this data collection process. It's just part of the contract. Yeah, the next step after that is automation. Then you get the dashboards. Do you remember the dashboards? Then the data is collected automatically, it's analyzed, and then presented automatically. And the idea is that it supports decision making. The problem with dashboards is that dashboards tend to be static, and the markets and the context in which they operate move. So then there is the next level, which is data innovation, where I will use one of the companies that we've done a little bit of work with that build mobile games. Yeah, you all know mobile games. They tend to be freemium games, yeah, so you can play games like puzzle games. They're free to play, but sometimes when you get stuck, you can do in-app purchases. Yeah, you can buy something like a diamond or something like that in order to. So what happens in these companies is that they have data analysts constantly looking for interesting patterns in the petabytes of data that they have. Once they find something interesting, they go to the relevant R&D and management team and say, hey, we found this, do you want this on your dashboard? And when the team says yes, something else gets taken off and this gets put on. But it doesn't stop there. What these companies do is once they really understand the correlation in the data, they will go and put this in the code. So for one of the companies that we work with, if you're playing one of their games, 90% of the CPU cycles will go to analyzing player behavior, which means that while you're playing, the first analysis that will start, if this is a puzzle game, is, are you stuck at this level in the puzzle? And if the answer is no, then the game does do nothing. If the answer is yes, the second analysis will start. And then the second analysis is, how likely are you, dear player, compared to millions of other players, to buy a little diamond from us to help you solve the puzzle in which you're stuck? And if it turns out that you're likely to shell out a few euros for a little diamond, the game will just let you suffer. If it turns out that you're not likely to buy a diamond from the company right now, then the next analysis starts. And that analysis is, how likely will this player be to buy a gem at a later stage in the game if we only help the player get there? And if it turns out that you're unlikely to buy a diamond now, but you are likely to buy a diamond when you are later in the game may decide to give you a free gem just to help you get there. That's cool, right? Everyone is looking at me like, Jan, that's cheating. No, this is actually running a business. Yeah. Anyone here using Spotify? Yes, so lots of hands go up. Good, Swedish company. Yeah. So the interesting thing is, why do most people use Spotify? Not just to listen to their own music, but predominantly most people I talk to use Spotify because it helps them find music they would have otherwise never found themselves. And again, that is a more benign use of data. Yeah, because there you are actually benefiting from the data being used to help you find new data. The last stage here is when everything in the company is driven by data. Yeah, so when I worked in Silicon Valley, I several times met people from Google, and the way that they described the performance evaluation process at that time is that your boss had nothing to do with your performance evaluation. What happened was that 6 people were asked to give feedback on you, 3 from the same team that you're part of, and 3 from other teams that you interact with on a regular basis. And as part of their evaluation process, each of these individuals had to give 3 names of people that they felt performed less good than you, 3 names of people that they felt performed as good as you, and 3 names of people that performed better than you, according to them. Now, if you, for every employee in the company, from 6 different people, get 9 different names, you can actually calculate a hierarchy of the most valuable employee in the company to the most useless employee in the company, and then salary increases and bonuses and all kinds of other things just become a mathematical formula. How cool is that? The enthusiasm isn't actually really there for some reason. Yeah, but in any case. But that's what evidence-based companies do. Then every decision process in the company is done through data. The reason I'm hammering so much on data is because of all the companies that I work with, I've noticed that the more the company follows this mantra, in God we trust, everyone else bring data, the more the company follows this mantra, the more successful they are. Yeah? And why I care so much about this is for this very old study that has received a little bit of flack in the past, which basically says, and this is done by the Standards Group, that basically says that somewhere between half and 2/3 of all the features in a typical system are used so seldomly that it's actually not worth, they shouldn't have been built in the first place. And you know, we felt that this might be true, but we didn't know for sure, and what we did was we did our own research with a company in Gothenburg. And what did we see? We again saw exactly the same pattern. So some features are used a lot, some features are used occasionally, and then the vast majority of features is never used, or at least used so seldomly that they shouldn't have been built in the first place. Yeah, so every company I walk into, I basically tell them, half of all your R&D is waste, you just don't know which half. Let me help. Yeah? You see the implications of this. It means that of all the thousands and thousands of people that are out there in the world building software based on how we educate them, half of them are wasting their time on stuff that doesn't add any value to customers. There is some room for improvement here, don't you think? Yeah, I think so, at least. So one of the things that we did was, and this is a very simple model, once you reach continuous deployment, and once you're able to get real-time data back from the field, you can change your development process. Yeah, so I have my product here with a product goal that results in a feature backlog. I pick a feature out of the backlog, and the first thing I do, and for those of you that have worked with product management will understand how important this is, the first thing I do is I sit down with product management and say, if we build this feature, how will the behavior of the system or the behavior of the customer change because of us having added this feature to the system? And once we have, and this is the expected behavior, once we have agreed on the expected behavior, then I build the minimal viable feature. Yeah, which is the first 10-15% of the feature that will, I think, or I hypothesize, give me the highest return on investment. Yeah, will have the most impact. And then I get it out into the product together with instrumentation that allows me to measure the actual behavior. So once I have the actual behavior, I can, and it's the functionalities deployed, it can actually, I can start to collect data, and then I can compare the expected behavior with the actual behavior, and then one of 4 interesting things can happen. One of the things that can happen is I may have built 30% of the feature, but I've already closed the gap, and there's actually no point in building the rest of the feature. So I just continue and move on to the next feature. The other thing what may happen is I've built the first slice, there is no movement in what I thought I was going to see movement in at all, and because of that I decide to abandon the feature. Clearly it was a bad idea, so I should move on to something else. The alternative is I see some movement, but not as much as I would want. So what I do is I extend the feature, so I build the next 10-15% to see if I get improvement then. And the alternative, and this has happened in several cases, you look at the data and you understand that the way that you realized the feature was completely different from how the customer was actually wanting to use it. And what then happens is that I have to implement, I decide to throw away my existing implementation and replace it with an alternative one. Yeah, so this is what we call the HyPEX model. Ecosystems, I don't want to talk too much about this because I want to speed up a little bit, but you remember this model, the 3-layer product model that I introduced in the beginning? I have now asked well over 50 companies how much of your resources are spent in the commodity layer, so what percentage of your R&D resources are spent on commodity functionality, and what percentage of your R&D resources are spent on differentiating, innovative and experimental functionality. And the answer I'm getting is that somewhere between 80 and 90% of all functionality or all R&D resources in a typical company are spent on commodity functionality. Think about what that means. It means that for every 10 people in an R&D organization, only 1 or 2 are building new functionality, and 8 or 9 out of every 10 in every R&D organization are working on stuff that no customer gives a flying hoot about. They don't care, it should just work. Yeah? So this is the state of software engineering today. 8 or 9 out of every 10 work on commodity functionality instead of adding value to customers. And the 1 or 2 people out of every 10 that are building new functionality, half of the time they build stuff that turns out in the end not to add any value to customers. That's the state of software engineering today. And I think that as a community we can do much better than that state. Is that fair? Yeah? Now, what we've done is one of the things, and this brings us then to ecosystems, and I will not talk in that much detail about it because I'm starting to run out of time, is what we basically say is following the 3-layer product model, I have 3 layers of 3 ecosystems. I have an innovation ecosystem, a differentiating ecosystem, and a commoditizing ecosystem. And what happens is that you can partner in different ways in these different ecosystems. Again, I don't have time to go into detail, but one of the things that I want to talk about is that this 80 to 90% is not a law that is driven by nature. We can actually change it. So what happens is that what I can do is I can use a set of different strategies in order to lower my investment level in commodity functionality. So if we look here at 3 companies, a large Swedish telecommunications company, who I shall not mention, actually Ericsson, whenever they have a commoditizing platform or product, they basically ship it off to a low-wage country. They keep it inside the company, but basically the engineers that are maintaining that product or platform get paid a fraction of what Swedish or Western engineers are paid. Another approach is something that Volvo, BMW, and a few other car brands did, is they together created the Geneva Initiative, which is a platform for infotainment systems in cars. It's a Linux-based platform. They together created it because they basically said, you know, it's a platform that is commodity anyway, we all need it, so why don't we partner on creating the commodity platform so we can use our own resources to differentiate on top of that. So that's the OSS creation strategy. And then finally, Access Communications works with the Linux community, so whenever they have video processing functionality that they consider to be starting to be commodity, they work with the Linux community to have the Linux community adopt that functionality into the main branch of Linux. And when they do that, the Linux community gets early access to highly differentiating functionality, and Access is able to reduce their maintenance costs to zero over time. So this is actually, there are several strategies that you can employ for reducing some of this. And I wrote a short book, if you're interested, send me an email, about 100 pages, where I explain how you can work with the 3-layer product model in this context. Empowerment. I wanted to spend a moment on hierarchical organizations. This is deliberately researched from Gaping Voids. Yeah, but for most hierarchical organizations, the losers are at the bottom, the clueless are in the middle, and the sociopaths are at the top, right? You know that one. So what we've seen is that there is a similar stairway where organizations go from traditional to agile, working agile, to working empowered in a cross-functional fashion, to self-managed and empowered. And again, I don't have time to go into it, but what I want to stress is that I believe we're starting to reach the end of hierarchical organizations. Yeah, and what does this mean? Why do I believe that? Well, hierarchical organizations have a set of strengths. They are very effective scaling, they allow you to control many people from a central position, they're very efficient for repeatable tasks, they allow for harmonization of processes, they handle globalization well, and they handle low complexity situations well. But here's the problems with hierarchy. They tend to have very slow decision-making processes because everything else has to go up the hierarchy and down the hierarchy. Power is driven by position, not by capability. I've worked for bad bosses in academia, but I've really worked for bad bosses in industry. Yeah? Idiots that should not have been in that spot to begin with, but they get their power from their position, not by their capability. The tendency to be internally focused. I can read from the slide if that would make you feel better. Yeah? It easily gravitates to politics. It's highly resistant to changes, and it is very much challenged by high complexity situations. So we can see this because if you look at employee engagement values, this is the US employee engagement. Around 30% of employees are engaged in their job, meaning that they're coming there because they're passionate about what they do. Around 50% of employees are not engaged in their job. And then around 18% of employees are actively disengaged in their job. Do you know what that means? It means that they will try to harm the company if they can get away with it. Yeah, this is when no one is in the office, you try to kick the printer and try to break it just to incur some cost for the company. Or if you're the truck driver working for the company, you try to dump the packages as hard as you can in the back of the truck, trying to make them break things. Yeah? So there are all kinds of subtle ways in which these people will try to harm the company. And now you can say, yeah, Jan, but this is the US. Of course, in Europe, it's much better, right? You know, here are the Swedish numbers. 16% of employees are engaged in Sweden. 73% of employees is not engaged. And only 11%, that's the only good news on this slide, only 11% of employees is actively disengaged in the company. Yeah? And the interesting thing is that this is becoming more and more a problem the younger you are. So traditionalists are pretty happy by and large. But if you look at millennials, no one likes to work in a traditional hierarchical organization. And this is costing companies lots and lots of money. So there is a new set of organizational principles appearing, which I think is quite interesting because it allows us to move to a model where we do away with bosses. And I will only spend a minute on this, but the idea is that we have self-management. You do not have a boss. Yeah, you have coordination mechanisms, but no boss. There may be natural hierarchies that form for a limited period of time, but no permanent reporting relationships. I'm not sure who remembers IBM from the early 90s, but if you worked for IBM, everyone was wearing a blue suit, white shirt, and gray tie. That was your company uniform. The whole notion here is that you can bring your whole self to work. If you want to look in a certain way, you're free to do so. Yeah? And then finally, rather than having a top-down strategy being forced down your throat by some incompetent CEO, the idea here is that you have evolutionary purpose. Yeah? There are a number of things, but the interesting thing is there's something called the advice process. There's an interesting book by Frédéric Laloux called Reinventing Organizations. And what he basically describes is the advice process, which means that in order everyone in the organization can make any decision he or she needs to take that pertains to his or her role. So if you're a blue-collar worker working in a mechanical production plant, you have the right, you can decide to order a 1 million euro machine. That's perfectly fine. Yeah, that's in your scope of responsibility. But you are expected to ask everyone who is affected by that decision for advice. So you go to your colleagues and you ask, what do you think? You go to sales and you ask, hey, if we buy this machine and we have this higher production, can we actually move that much goods? You go to finance, can we afford buying this machine? And all these people will give you advice. But in the end, even if not everyone supports your decision, you can still move ahead and order the darn machine. Yeah, because I used to think that there are two ways of decision making. Either you have a hierarchical boss and the boss decides, so you have to go to the high enough hippo in the organization. You all know the term hippo, highest paid person's opinion. Yeah? No? Okay, either you go up the hierarchy and have someone decide, or you need to have some kind of kumbaya consensus moment where everyone has to say yes before you can do anything. Yeah, but the advice process actually takes that deadlock situation out of the equation, which is a really interesting one. And if we look at examples, I think we can see that Agile is actually a first step, because Agile teams have a lot more autonomy than other types of teams. There's something called, in this book that I just mentioned, Holistic Organizations, where he basically describes that society is moving from tribal to agrarian to the scientific industrial to the postmodernist to what is now called holistic authentic organizations, or also sometimes referred to as teal organizations. Holacracy is one of those methods. Zappos, now owned by Amazon, went to Holacracy last year. And then there is this notion of exponential organizations, which is a book which explains how companies like Uber and Airbnb can grow so phenomenally fast by basically focusing on clear interfaces, dashboards, experimentation, autonomy, and social media inside the company. And then outside the company, they have staff on demand, a community and crowd around them, algorithms. Yeah, if you drive for Uber, I think you know that you work for an algorithm, right? You don't work for a human being, you work for an algorithm. There are leveraged assets and there is engagement, yeah, that they use basically. So what is happening? We're moving to a world where we move from orders to principles, from a boss and a follower to personal leadership, from audits to trust, from organizational structure first to customer first, from manager-appointed teams to team-appointed managers, from homogeneity, everyone has to be the same, to diversity, from long-term planning to agility, and from top-down strategy to emergent strategy. So there is a shift happening not only around how we build software, how we work with data, how we engage with the ecosystem, but even to the very core of how we organize our human institutions. And I think that that's what I wanted to get across. Conclusion. I guess you're ready for a cup of coffee, right? I guess there's a coffee break after this. I don't know. Yeah? A few slides. One, in the future, all companies will be software companies. As I think David mentioned, it's a good time to be in software. Everything is driven by software. Yes, there's data, and yes, there's neural networks, but I basically included in the whole software/digitalization journey that we are all very much at the core of. Yeah, so that's important, and that's a good thing. So the 4 takeaways. 1, increasing speed trumps any other improvement R&D can provide to the organization, and the goal is continuous deployment in basically every product and system that we have. And why? Because it allows me to get a much faster feedback cycles. Data is kind of sort of important. We can use data to make much higher quality decisions. In software engineering, we're moving from efficiency. How do we build requirements that are thrown over the wall by product management? How do we build those requirements as fast as possible? That's efficiency. To effectiveness. How do we make sure that every dollar invested in R&D translates to as much revenue as possible? And there, data can play a very big role. Ecosystems. I should focus my own people on the differentiating ecosystem. And I should partner with others for commodity functionality, and I should partner with others to maximize the amount of innovation I bring into the organization. And then finally, I should move away from hierarchies and look for ways to increase the empowerment and autonomy of individuals. And this is happening in a variety of actually very, very successful companies. If you're interested in some more material, here are some 3 books. This is a thicker book that you can buy. It describes most of the things that I talked about except the empowerment dimension. There's a short book here describing a little bit about a fictive startup that starts to work with data, and this is about the 3-layer product model and how you decrease your investment in commodity functionality as an organization and the different mechanisms that you can use for doing that. And with that, my friends, I would like to thank you very much for your attention. You can find Software Center here. You can follow me on LinkedIn, Twitter, or on my blog. And with that, thank you very much for your attention. I appreciate it. I'm not sure how much time we have for questions.
Well, we have time for a couple of questions. So one question that is coming from the audience, we are collecting questions to Slide.do, is what are the societal dangers of an excess of digitalization, in your opinion?
Yeah. So I think that that's a really good question. I mean, one of the topics, I think Facebook is in the news right now. Some of you have noticed that. Yeah, so of course there is this notion of data and privacy. And I think that this is an interesting misconception that happens in many people when they think about data. When I worked for Intuit, one of the roles that I was our relationship or our connection to MIT Media Lab. And at MIT Media Lab, one of the professors there wanted to learn a little bit more about the people's perception of privacy and how they were handling things. And they went to a mall with a big box of chocolate, and they basically put up a table, and they said, with a big sign that said, "Give us your password, get free chocolate." So the idea was you would give them a password that you use, and you would get a piece of free chocolate. They had to get new chocolate 3 times. Yeah, so I think that it's clear that you have to understand that when there is a value exchange taking place, and you are aware of the value exchange that takes place, most people are willing to accept that situation. That's the first thing. Second thing to realize, when companies are running A/B experiments using data, they don't care about you per se. What they care about is large groups of customers and trying to understand whether version A or version B is better. Yeah? Having said all that, I fully agree that there is no reason why anyone should be able to collect personally identifiable information about me and then look for ways to monetize that. That, I think, is a big no-no. So there are, of course, risks. Yeah, but what the right mechanism is to address those issues where we get into personally identifiable information is, I think, an interesting discussion where I do not have a good answer. But the majority of companies, well, let me rephrase that. At least many of the companies that I work with, the way and the data that they use is not used to figure out who you are and what your preferences are and try to break your privacy. They're just trying to make their products better for you. But then again, you know, I think you know that Facebook makes $15. For anyone in this room that is on Facebook, Facebook makes $15 a year from you. Yeah, but you get to use it for free. Yeah, so there is a value exchange right there. So that was the first. So I talked a lot, but I didn't really give an answer.
Just one from Slido, but I want to hear the answer. The question is, effective use of data from customers is key to success. Will the GDPR be a major obstacle?
I would love your phone too if you want. No, I'm fine. So here's the interesting thing. So GDPR is an obstacle, but not in the way that you think it is. Many of the European companies I work with are so scared of GDPR that they have chief data officers that basically refuse any request from any product team to collect data. Yeah, so they just say no. Oh, we would like to collect some data. No. Yeah? So what I see is a situation where European companies are so scared of GDPR, that they don't do anything because they don't know how to work with the regulation, basically. And at the same time, the companies towards this law was directed, and I think we can talk about a number of them, but I don't think I have to mention the examples, but typically they tend to be American-based in Silicon Valley, etc. Yeah? They are just pushing the boundaries of the law, and they're getting everything that they can in terms of value from working at the very boundary of GDPR. So what I see is that European companies are not benefiting from working with data because they stay so far away from the boundaries that the regulation has put in place that they're not getting any of the data and any of the benefits. Whereas the companies for which the law was intended are basically just riding as close to the edge as they can and still get the benefits from working with data. And I think that that's one of the implications of GDPR that I worry about. And my apologies for all the Americans in the room. I'm sure you're very well-intended people. Should I run up with the microphone, or who do you want to give it to?
Very last and quick question, yes.
Yeah.
Very last. Over the coffee break.
I'll be here for Yes.
So I just have a question about your categorization of features as, frequently used, infrequently used, and not used at all.
Yeah.
I wonder if there's another dimension to that, like infrequently used features that are actually really important as well, right? Like, for example, to use your phone thing, I don't make phone calls unless I have a really severe problem. Right?
Yeah.
Infrequently used feature, but if it doesn't work, it's a bad situation.
Yes.
Just wanted to know about your
So,
thoughts.
I only showed one slide out of 5 years of research in this area. Is this too loud? I will try to keep the microphone further away from me. No, it's okay. We have developed something that we call the feature types model. Maybe this one is better. And the feature types model basically says that there are 4 types of features. There are regulatory features, things that I need because otherwise I cannot sell my product. Yeah, so in mobile phones, you have to be able to do call 112 or 911 without having to unlock the phone. Yeah, that's really important. The second is what we call competitor matching features. My competitors have some feature, I need to have that same feature because otherwise my customers will not even consider buying my product. Then there are wow features. Wow features that are built only for marketing purposes. Yeah, a good example of this is Sony Mobile. They had in their camera app, I'm not sure who has a Sony phone, not that many because their market share has dropped a little. But in the camera app, they had one view was the globe, where you would see an Earth globe, and you would see on the globe where all your pictures were taken. Yeah, for most people, this is a totally useless feature because they don't travel very much. So when they look at the globe, there is a completely empty Earth, and only in one spot on the planet all the pictures were taken. So it's completely useless. But the journalists, they loved this feature. Yeah, because they imagined this jet-set lifestyle where I wake up in Rome and I take a few pictures and I fly on to London, take a few pictures, fly on to New York, take a few pictures, and then I meet my friends in, somewhere in Asia over drinks, and I can flip through my globe and show all the pictures that I took. That was their mission. Yeah? So they really loved that feature, and they actually gave the phone very good ratings just because of that. So that's a wow feature. And then the last type is flow features. The features that are intended to be used by customers on a continuous basis. The data-driven development practice we're talking about here are predominantly intended for flow features. And there are other types of features that are there for which you should just build according to the requirements specified in the regulation and be done with it. But also build as little as possible. So you're absolutely right. There's a lot of thinking behind this that I couldn't get into during this talk. Well, great question. Thanks. Already?
It's late, so but you can continue doing the coffee break. So let's thank again Jan for this.
Jan?
Hold on.
Yes, you should have.